Thank you. So yeah, welcome everybody. So this presentation is going to be about a three-pillar governance model powered by the Databricks System Tables and Lakewatch. So let's first start with a quick round of introduction. So as Jeanette correctly stated, my name is Frank Bonu. I'm a data engineer at Xebia Data. I have a little bit more than 3 years of experience at Xebia Data, and a little bit more of about 6 years of experience in the software engineering industry.
Yeah, so my name is Cristiano. At this moment, I'm the principal engineer of the ASML Data Analytics platform. Basically, it's a central platform. All the machine data from ASML comes from the different customers, and we centralize that data, and actually now we are responsible for enabling the AI services on top of this platform. So actually it's getting quite big within the organization. My background is more in computer science, so parallel distributed computing. Naturally, I moved my career towards big data processing and so on. And I worked on this field, IT and data, for about 15 years. And a side note that indeed before joining ASML, actually, I was also working with Xebia, where we actually started our nice connection, right, Frank?
Yes, exactly. So yeah, let's go over the outline of this presentation. So first we'll start with the double-edged sword of federalization. So ASML has a federated data architecture, and we will go over the double-edged sword of that. So first we'll start with a brief introduction, what role data plays within ASML, why ASML chose this federated architecture, and then the emerging problem that comes out of this federated data architecture. We'll move to our solution, which is a three-pillared governance model. Then we'll move to the impact, so actually use cases, and then we'll finish with the conclusion and a small demo. So yeah, with that, I would say let's start.
Yes. So maybe a brief introduction about ASML. I don't know if all of you are aware of it. We know that's a really big Dutch organization, but sometimes still some people don't know about it. Then I like to explain a little bit more. So basically, ASML is responsible for building lithography machines. So basically, if you have a Samsung or Apple device, most likely the microchip was built by one of the ASML machines. Especially because of the latest technology, so the UV, extreme ultraviolet. Basically, ASML has kind of a monopoly of the market, especially now with AI. Then indeed, there is a lot of demand for more microchips, and then basically the ASML machines are in the center of everything. That indeed comes with a lot of opportunities, but with a lot of challenges, because indeed, I think there is an article on the New York Times that ASML is building the most complex machine in the world at this moment. Then indeed, several different components, latest technology, cutting edge, then also a lot of things can go wrong. So how we can have the proper insights to troubleshoot those machines, but also to keep improving on the design. And actually, that's where data plays a key role. Our daily activities, so you can see that ASML uses data for various purposes. The first one, I think that's the most obvious one, is machine diagnostics. So indeed, if something is going wrong, let's say especially for customer support, how we can have data on time to actually troubleshoot that machine. Because if machine is down, also because of the SLAs, then ASML sometimes is punished with really severe fines, and then indeed how we can prevent that, and actually then prevent that the trust of customers are going to decrease. Obviously then the way to try to circumvent the situation is more with predictive maintenance, how we can predict if maybe a specific component of the machine is going to fail. Now we have a lot of different use cases around it, actually pretty successful use cases. Actually, I've heard that even the challenge now that we are so good on those models that maybe now the second question is, maybe we should wait a little bit longer to replace that part, because is that the optimal moment to change it? So indeed, that's I think the challenge is when you have really good predictive maintenance models. Obviously for operations, you can think about supply chain, also HR, finance, then how we can support this part. And obviously then how we can have the whole product development and innovation part in place. Probably also you've heard that ASML put, I think, 1.5 billion on Mistral. Then also how we can start embedding AI into the machine itself. So then also basically data plays a key role on this whole landscape. And that's why indeed ADAP, the ASML Data Analytics platform, is so important within the current scenario. But obviously, at this scale, we have a lot of different challenges. I think same as other companies, we start with a more centralized model managed by IT. but all of a sudden that indeed IT becomes a bottleneck. Also, IT lacks the domain knowledge, and ASML is quite complex, so indeed it's about lithography, laser, physics, and then IT basically cannot provide with this domain knowledge. Also, it's quite hard then to centralize the resources over there, how we can meet the data organizations across the organization, then that this centralized model was failing quite hard, if you ask me. And then also, if you see data analytics is distributed by nature. So indeed, how we can analyze that in the different sectors, different domains. And in this case, centralization for sure is going to become a bottleneck. And also, when you have your data pipelines built in a single data platform, then it's going to require a lot of coordination in order to do that. If you have decentralized, all your data engineers are part of IT, for example, business analysts, then IT becomes quite complex over there, and also requires to develop some aspects that basically is not there. So basically, with these challenges, then obviously start thinking about possible solutions. And then indeed, if you see on the top part, so it was the old way of organizing ourselves, so more centralized. So you can see that indeed we have machine data. That data is sending data to our landing zone. We would unpack this data, saving to our raw data layer, clean that data, and then we'll make data products available. But then IT will do this whole thing. But then indeed, in order to allow IT to do that, then indeed we'll need domain knowledge, we need a lot of people, a lot of coordination. Then we said, you know what? Let's try to move into more business domains. Then IT is responsible for the first part of this picture. That indeed IT is responsible for making sure that we are receiving that data, we are unpacking it, and then when, let's say, I save that on the bronze layer, and now is ready for the business domains to basically start adding the business logic, and then also creating the data products, and then also preparing that for the consumption, because they are the ones who know the best what they would like to do. So basically, that's the transition phase that we are at this moment. I think we started this movement around 2 years ago, and I already see a lot of benefits on organizing ourselves with this, let's say, more federated architecture in place. And what we can achieve with that. So indeed, we like to move from delivering solutions to actually providing reusable building blocks. I like this analogy. That's basically the old situation. It was some building blocks that actually was quite hard to put them together. And actually now with more standardized building blocks, then indeed you can combine them basically to meet your requirements and your needs. Then indeed you can see as benefits, then basically indeed we have flexibility, also have faster development and easier maintenance time because you know the ins and outs. People know how to combine what's already there, and then also we see that we become more efficient, less waste, and also then we become faster on moving things to production. So basically that's more in a nutshell the introduction about where we were, the challenges, and actually the direction that we are heading towards. And basically, to summarize our view, because that's going to be key, this slide, and to understand the remaining of this presentation, then for us, a data product that indeed we like to have that should be discoverable, addressable, trustworthy, subscribing semantics. I think this one, if you search for data product, basically that's going to be the definition of it. But if you see basically a data product, we call trusted data set for now, is based on 3 main pillars. Source code, basically what's the code that I have over there, for example, for the transformation, for my data pipeline. I have the infrastructure itself, my, let's say, database workspace, the job clusters, workflows, and also have the data itself, but also metadata. And basically those blocks, they have their own requirements and come from different parts of the organization. To be honest, one thing that we are missing, especially because you can imagine that those machines are producing a lot of data. Just to give an example, the latest model is producing per machine, I think, is 5 terabytes of data per day. ASML has hundreds of those machines in the field. Then indeed, if you don't do that properly, from a cost efficiency perspective, we would waste a lot of money. And then that's also why we mentioned, okay, cost efficiency is an important aspect that we like to add as part of the data product. And the remaining of this presentation is to cover this part. And then how we can meet all those requirements from different parts of the organization, because if it's about code, ASML has the software engineering requirements, but also have the industry best practices. For infra, we have the Cloud Center of Excellence, so how we can meet their requirements. And for data, metadata, we have the Chief Data Office, so indeed how we can meet those requirements. And then what you're going to present today is the way that we have decentralized governance model while operating a more federated way. I think
so thank you, Cristiano. So now we'll go over the emerging problem. So autonomy without accountability. So you would have teams that would use a different set of standards. So you would have maybe a team that would decide to use techie X, and team B would use techie Y. They would actually present the same semantic entity, but because the standards don't align, you're not able to backtrack this effectively. So a solution would be, right, to have a central team, but this, of course, would become a huge bottleneck within your organization. And this all leads to poor best practice adoption. First of all, it leads to poor alignment. And if you don't have proper alignment, you cannot align on the best practices, right? So you would have a team that would lack the observability and the knowledge to, for example, upgrade to a higher Databricks runtime version. And all in all, there is no autonomy. There is autonomy, but without central accountability. There's no platform where teams can see how well they're performing in terms of their maturity, best practice adoption. So yeah, you cannot improve. So now let's talk about our solution. So we propose a 3-pillar governance model. So it might, it's the ERD of basically the Databricks system tables. So Databricks system tables is basically a Databricks hosted analytical store of your account's historic operational data. So a lot of words, but what it actually means, so you can see, for example, how your job is performing, but also how much this job has costed, when it has failed, but also audit logging, who accessed a certain table at what time. So as you can see, it's really raw, granular data. It is designed for joins. This is really powerful raw data, right? But the key question that remains is, okay, can we transform this raw data into rich insights? If we would just query these tables, it is not actionable yet. We cannot derive an action from it if we would just read the raw data. So the second pillar is Lakewatch. So Lakewatch actually solves this. So we at Xebia developed an internal observability toolkit for Databricks, which is called Lakewatch. We can deploy it natively within any Databricks environment, and it uses 3 core metadata sources. So the Databricks system tables, Delta table metadata, and cloud storage reports. So the latter 2 are external storage metadata sources, and the system tables, it's more focused on compute. We use dbt as a powerful SQL transformation framework to transform these raw data to really rich, aggregated, actionable Databricks usage insights. And a use case would be that you would have a table that would have too many small files, which can have a negative impact on your compute performance if you need, for example, 100,000 of files for a table that's maybe 10 gigabytes. The overhead of reading these files will negatively impact your compute performance. And similarly, we could also check the compute efficiency of your clusters. You might have a job that runs on an over-provisioned cluster, which would result in wasted costs, wasted usage. So let's go for an example. So here you can see the raw system table data. So you see on the left-hand side the node timeline, on the right-hand side the job run timeline. It's really granular. So this data is stored basically on a minute level. You can see the utilization for a specific cluster. And on the job run timeline, you can see the compute ID that the job has used. So you can actually join the two to get a utilization for the specific job. So that's also exactly the question that we would like to be interested in, right? Like if you're a manager and you would like to understand, is there over-provisioning within my Databricks account? You would have this question, okay, do Databricks jobs make use of an over-provisioned cluster? Yeah, we can see that these tables are well suited to answer this query, but they are not actionable yet. We can query this table, but we will not have an idea what to do. It's too granular yet. So Databricks does provide native monitoring, right? You can go to your job cluster and then you can see the metrics over time, and there you can nicely see the idle percentage for a specific job. But of course it would be cumbersome to do this for every job within your organization. You could have thousands of jobs, and it's not practical to analyze this per job. So you would want a central place where you could analyze this. So first we need to define when a cluster is over-provisioned. So a cluster is over-provisioned when it has more resources allocated to it than it is actually using. And we can look at the 95th percentile of usage to determine this threshold. And one thing we found in our journey is that we cannot exactly use this 95th percentile usage because it's not scalable. We cannot sum the percentage, this utilization percentages of jobs to each other and then present this to leadership. We need to come up with a smarter way to derive, okay, this job is maybe running on a smaller cluster and it maybe is over-provisioned, but the additional benefit of downsizing it doesn't outweigh the effort required. So you would want to first understand what is the total impact on usage. So in Databricks that is DBUs, Databricks resource units. And the result is that we have this aggregated table. So Lakewatch created this table where you can easily see on the job name, the workspace name, the total DBU savings, the start date, the worker instance, and the utilization statistics. So you can see that for the CPU, we are not really on the desired level. And we can also see the recommended worker instances. So it recommends basically a more memory optimized instance rather than this compute optimized instance. And this already looks a little more than the data that we get. It's really actionable. We can actually answer or query. But still, let's visualize this. Nobody's going to query all these tables to get these insights. I think it's nice if we can maybe have a dashboard that actually visualize this data. So we also created dashboards. So on the left-hand side, you can see the operational view of your job. So you can see the performance of your worker and driver nodes. And then in another tab, you will basically have a list of downsizing opportunities and the recommended worker instance types. So as shown here, the CPU utilization is really low. It's below 5%, while memory is more at the normal level. So it wouldn't make sense to move to a more memory optimized instance, right? We're not really using our CPU cores, whereas memory is quite utilized. So maybe it's better to move to a memory optimized instance, which is more cost efficient and is better fitting this specific job. So next, Cristiano will talk about this third pillar, which is Cortex.
So basically that indeed, as Frank mentioned, now we have ways of getting insights from our systems of record, but indeed cost is just one dimension of it. But indeed, what I showed you earlier, also have infrastructure, we have data, metadata requirements, so how we can centralize these requirements, because on our side, if you see on the left side, you have indeed data coming from ServiceNow, Azure resources, also have a footprint on GCP, then we have GCP resources, we have data coming from Databricks, we have data coming from Azure DevOps, let's say repositories, pipelines. We have data coming from our own platform, and also have data coming from Flexera. Here's more like a cloud cost management tool. So how we can consolidate data from those various sources, then that's here where Cortex is a third-party tool that we are using that allow us to create a custom knowledge graph. Let's say how we represent our organization. We have cloud workloads, we have data producer use cases, we have trusted data sets, we have vulnerabilities. So how we can create this custom knowledge graph, so how we can ingest and hydrate this knowledge graph, because then when the part is in place, we can define the ownership, so who is owning those instances. Because then that's the nice part, then we can start defining scorecards. So scorecards, we can think about an onboarding scorecard, trusted data set production readiness scorecard, trusted data set operational maturity scorecard, best practices for Databricks, for example. Then we input our requirements, and then Cortex is going to continuously assess and evaluate those scorecards based on the data that we ingested. And then this can be exposed through REST APIs, but also now as using the MCP protocol. But why we want that? Because that indeed we can basically enhance the quality and compliance of our business applications. Our platform itself, the trusted data sets, but now the AI workloads that we are creating at ASML, and also the more traditional analytics workloads. Let's say I have a reporting tool, or I have my application that I need to have the embedded analytics. So how can I make sure the quality and compliance is there? But also at the same time, I can enhance the engineering workflows. Let's say for engineers who are creating those data sets, engineers who are creating those AI workloads. Obviously now we're putting a lot of money on Mistral, also have the Mistral code assistant over there, but so far using a lot GitHub Copilot, and also basically how we can embed that into our CI/CD pipelines, more on a shift-left approach, so how we can bring those insights and meet developers where they are. And then indeed that's our approach. We extract this data, we expose this data, but then most importantly, we empower engineers and our AI with the right context to take the right actions. And we start embedding that into the normal flows. Then, because in the past, I would need somebody to fill an Excel file, so the other person need to review. So we start replacing those manual checks by automated processes, consuming those scorecards. And then also we start embedding, as I mentioned, CI/CD pipeline. So in a nutshell, that's indeed the last part of our solution. We are going to show you later, indeed, a demo on how it works, but I think it fits quite well into what we are looking for. Then now we have a central place that we can define our requirements. We have automated and continuous checks, and then we empower our engineers and also now AI with all this information in a single place. Here you can see an example what kind of reporting Cortex allows us. So you can see this Databricks best practices scorecard. Then you can see that indeed we can specify, okay, I like to apply this scorecard to specific entities, let's say to all mission critical data sets or to all customer-facing workloads, because we have this metadata coming from ServiceNow, for example. And then you can also say, I like to assess that every hour, the data that I have, and then it's going to assess here, we just, let's say, remove the names, but then he would be on the Databricks workspace level. Then we can see per Databricks workspace, what's the current level. You see a lot of fix ASAP, and if I click, I see which rules are failing, and then I get more insights of what needs to be done. Then again, we start empowering users to take the right action. I'm going to show you more in a real example with the demo in about 5 minutes from now.
Yes, so let's recap. So our solution, a three-pillar governance model. So we can see on the left-hand side, we start with raw data, raw system table, Databricks system table insights. We use Lakewatch to transform that into rich, aggregated, actionable Databricks usage metadata. And then the data is ready to be exposed to Cortex. And there you can see that we create, for example, a Databricks best practice scorecard where you would have a scoring rule for a right-size cluster. You would have a scoring rule for the average table size within bounds or the average file size. And that way you can really gamify best practice adoption. You can really make it tangible for managers, for everyone within your organizations to follow best practice adoption. And now I will show you some actual use cases. So we do have some more tangible examples that would be good to understand. So here you can see a use case would be the taming of cloud cost. So a few things to point out here. You see a failure message where it says, okay, we're wasting over the past 10 days approximate of 1,700 DBUs, which exceeds a set threshold. We have a nice link to a Databricks dashboard, to a contact person if they don't have the access to access this dashboard, but also the ADAP docs, which is basically a central place where ASML stores their documentation for more guidance on downsizing. And last but not least, you also see the resources. You really you want to make it really actionable. So you can fill a rule, but if you don't provide the actual Databricks resources by job name and the actual recommendation, you don't empower the team to actually take action. So that's also a point that that will come through in the scorecards. We want to really make it actionable enough so that so that we enable self-remediation. So a second use case would be to monitor tagging compliance. You all may know that tagging is vital for your operational and cost observability. So also one of the key challenges, right, in a federated data architecture, we talked about that. And then you can create a scorecard where you can basically see, okay, which resources have the incorrect tags. And then you can alert teams and list the resources so that people can look at this job, correct the tag, and then the scoring rule will actually move to passing. So the third use case is general Databricks best practice adoption. So as I said earlier, you want to maintain a proper average stable file size. Here you can see that the deviation is too high with a desired state. Why it matters as well, right? Like really empowering users and transferring this knowledge to them with links to the Databricks documentation so that it's really actionable enough, so that they can take action to make this scoring rule pass. And now we have a demo that will basically show the use case.
Indeed. So basically, that's the interface of Cortex, more like to show you that you have, let's say, cloud workloads, trusted data sets, use cases, but then more like to show a more practical example. We have this data product trusted data set called ADC config. And then here we are going to get all the details about it. You already can see here the scorecards that are applied to this. Then you can see, let's say, from operational maturity is 29% level, fix ASAP. And if I click here, I can see actually what's failing. As Frank mentioned, that indeed we have some deviation in terms of file size. And also if I click here, then we have the logic, recommendations, and basically for my own case, there we have the context of this specific data set and why it's failing. So then you can see that indeed we can really empower users to do that. Again, also you can consume all this data from a REST API that, for example, my CI/CD pipeline, I could consume it. And if the level is lower than 70%, my pipeline might fail. Also, it's this kind of possibilities that we have in the future, because right now we still have a lot of human in the loop to check if you have the right levels. Also we are bringing all the metadata from ServiceNow, for example. Okay, what's the criticality of this data? What's the domain? If it's materialized as a volume, materialized as a table, view, then also we can use all of this to specialize our scoring rules. And then, as you can see here, we also have a lot of links to our own documentation. You see AdaDocs, so basically is our user-facing documentation. We have a section that's what we call the big data competence. Asmel is organized within technical competences, and we have the big data competence over there. Then we define what good looks like for development maturity, operational readiness, operational maturity. And then also what we've done, then to expose this documentation, because believe me, forget that people are going to go here and search by keywords. Then also in order to work together with Cortex, we create an MCP server in front of this documentation. We index all this documentation to make that more usable for AI. If you use Microsoft, probably you're familiar with Microsoft Docs, so the idea is the same, that you have a semantic search being exposed to MCP server. And with that, then enables these kind of use cases. So basically here what I'm going to show you is a recording that I was using GitHub Copilot, then to interact with Cortex and ADAP docs in this case. Let me maybe just slow down a little bit, speed. Then I'm going to explain what is happening. Then as you can see here, we have, okay, is this trusted data set how is performing in terms of cost optimization? Then the agent, in this case, Copilot, is going to search on Cortex, the Cortex MCP server, get some entity details. It's going to try to understand which kind of scorecards are applicable to this specific data set. The first trial didn't work, so now is let's say, opening up the scope. Then it's going to list the scorecards. Let me maybe speed up a little bit. Is going to get the scorecard score for that specific part. Also is going to check the operation maturity scorecard, what are the scores. And as you can see also here is going to the documentation to check more information about delta file size optimization. And now basically the LLM can summarize all this information. So you can see that indeed, in terms of cost optimization, critical issues, identify it. You can see why. So basically it's checking all the scoring rules that are failing. For resource tagging, we have some mixed results. For Databricks runtime version is outdated. Then basically what should be the priority of things to tackle, what's the financial impact of it. And also already providing the links to the documentation because was able to connect to our AdaDocs MCP server. Then here asking what are the potential monthly savings for the trusted data sets, as you are getting that from Lakewatch. Then basically is going to get more information from Cortex, the events that you are pushing. Has a lot of events, go to the second page, and now can, again, go to the documentation, AdaDocs, and now is going to create a more extensive analysis. So the total amount of DBUs that we're wasting on the last 10 days. Also providing some different categories of things that we can see. What's the current situation? What's the calculation of the financial impact? And then here, indeed, is going to provide some recommendation in terms of next steps, what needs to be done. So you can see that within 2 minutes, it was a quite extensive analysis that would probably take days or even weeks. It would be up to the user to go here and there. So now within 2 minutes, I have this information. Obviously, then the next step would be maybe ask Copilot, then please create a plan or change my code to be more efficient or more compliant. And I think that's what you're talking about now. So it's looking ahead and how we can empower users with these kind of interactions. Because indeed, maybe users, they don't even open the interface of Cortex. Because indeed, our vision is that we meet developers and engineers where they are. In this case, is on their IDE. And we start centralizing. Because as Frank mentioned, maybe one approach is, OK, go to dashboard 1, dashboard 3. But then it's up to the user to understand. Go to the stack documentation. But actually now here we bring a more context-aware approach. We provide this context to the engineer and to the AI then to have this kind of workflows. Then coming back to the presentation.
Yeah, so I think we're ready to conclude. So some key takeaways. So we now have a better measurable definition of maturity. We enabled the teams to adopt best practices, so best practice governance becomes enablement. And also, moreover, your platform's metadata is a goldmine for automation, so everybody can just access their system tables. And we've proved that it's a goldmine of information. We can see the usage of jobs. We can detect idle clusters, idle warehouses. So it's a perfect source. And lastly, we empowered engineers with this solution. We empower engineers to take the right actions. We transfer knowledge, and in that sense, we align best practices within our organizations to a higher level. So
yeah, I think especially about this one, because indeed, as you like to implement this more federated model, then it should be more self-service, because it's not doable that people are going to knock on a central team's door. Then indeed, how we can provide this information in a nice way. And as ASML has really high standards for quality, obviously the challenge is you have extensive list of requirements, and using the past would be some vague requirements in a PPT. So how we can translate that into a more comprehensive way of having the requirements, and then indeed to have a more live system that is checking, hey, by the way, you are 30% on your journey. Those are the recommended next steps. Then also, all of a sudden, AI start becoming this companion around the whole journey of an user. Otherwise, indeed, we need a lot of people. The lead time would be huge, and also the cognitive load would be quite high if you just kept doing what we were doing in the past. So basically, what's coming next? That indeed now we have this nice system. We are collecting insights. We validate it. We can trust that data. But obviously, I think it's only valuable when we can actually move the needle, right? We see a lot of fixed ASAP workloads. So how we can bring that to the next level? Within ASML, we work with the SAFe model, so the Scalable Agile Framework, and we work with product increments. So basically, every 3 months, all the teams sit together and we discuss the next 6 sprints. The nice thing, because now we really have the support from upper management, and they say, Cristiano, give us 1 or 2 KPIs that we like to move the needle on this PI, and then we set those targets, and then indeed we start integrating score-based discussions within the existing ceremonies. Sprint planning, sprint review, retrospective, inspect and adapt, because then people start talking about those metrics and also start validating what needs to be done. And then I think the second part is then we start moving from, let's say, really scattered resources to a more automated, simplified, and most importantly, user-centric workflow. As I already showed you, that indeed how we can embed those scorecards into our own user journeys, especially to eliminate manual steps. Share a funny fact here. I think 1 year ago we did an assessment, and the end-to-end journey to create a trusted data set would take 22 process steps, and six of those steps were manual, just somebody checking the quality and so on. I think we can replace at least 5 of those 6 steps with that. And I think the last bullet is what I shared here. I think that's the first small step towards what we call the AI-enhanced developer cockpit. So how we can provide this cockpit for developers, then they have everything they need to operate within that cockpit. And then obviously AI can help them a lot. So instead of them going around and understanding what's the situation, they can actually leverage Cortex, our documentation, AI, other MCP servers that we are about to release, then to be more productive, and at the same time then to have the proper quality in place and compliance. I think we are in a luxurious position because in the past was always a battle, right, between quality compliance versus speed of delivery. And I think with these kind of practices and solutions, we can actually meet both and at scale that ASML needs.